Hi everyone. This is a movie on Learning Target 2 reflections. So this first screen on our reflections, don't worry about it on your notes. It's an in-class activity. We'll get straight to the point of it. What they did was they took a piece of tracing paper and reflected a triangle and saw how those shapes were related to each other by connecting corresponding points and seeing how those corresponding points related to the line of reflection. And what we found was that, these need to be A prime, B prime, and C prime. What we found was that A to the line of reflection is congruent to the line segment of A prime to the line of reflection, and that C to the line of reflection is congruent to the line of reflection to C prime, and that B to the line of reflection is congruent to B prime to the line of reflection. So we also found that the line of reflection was perpendicular to all three of these. So another name for the fold is the line of reflection, and the fold is equidistant from corresponding points. And the fold is the perpendicular bisector of the line segments created by connecting corresponding points. So you can just fill those in, and that is true for every reflection, not just this specific reflection. So we'll apply it to this figure here. So we can draw these lines that connect line segments like this, right? And then we can see that from A to this is 3 units, and this is 3 units. This is 3 units, this is 3 units. C to the line of reflection is 2 units, and the line of reflection to C prime is 2 units, and they're all perpendicular. So yes, because this line of reflection is a perpendicular bisector to the line segments that connect corresponding points. Oh my gosh. Okay, so now we're going to look at specific examples. Reflections over the y-axis, so the up and down axis. So the pre-image is ABCD, this one over here. So that's what we're starting with. The image is what we get after we reflect, so A prime, B prime, C prime, D prime. So the input of the function is always going to be the coordinates of the pre-image, what you start with. That's what you're inputting, right? So we get A, B, C, and D. The output is the coordinates of our image, what we're getting. And D prime 3, 2. So then take a look at those, pause the video, and try to think, what is changing about these coordinates? What's different from the input to the output? And how could we write that as a rule? All right, I hope that you paused the video and took a guess. If not, you can see that the x values are becoming the opposite of what they were. If they were negative, now they're positive, and the y values stay the same. So what we get is negative x comma y. So when we reflect over the y-axis, it takes the points x, y, puts them into the function, and pops out negative x comma y. So we can say the same thing for the x-axis. The pre-image is A, B, C, D. The image is A prime, B prime, C prime, D prime. The inputs are all those points, A, B, C, and D. And the outputs are A prime, B prime, C prime, and D prime. So then if we look at those points specifically, A to A prime is negative 3, 4 to negative 3, negative 4. B is negative 4 comma 2, B prime is negative 4 comma negative 2. So as you can see, the x value stays the same, the y value becomes negative when we reflect over the x-axis, which makes sense because the shape is moving down the y-axis, right? And we see that orientation is flipped there. Okay. So then if we did this example, E, F, G, H, over the x-axis, if you look back, our rule was takes the points x, y to the points x comma negative y. So we can look at all of these. It'll take E to E prime, which would go x comma negative y, F to F prime, which is negative 2 comma negative 4, G to G prime, which is 3 comma negative 6, and H, sorry about that, to H prime, which would be 6 comma 1. Perfect. So then we move on. Now we're going to look over the reflection line, a reflection over the line y equals x, which is through the origin with a slope of 1. So inputs are A, negative 3 comma 4, B, negative 3 comma 2, C, negative 2 comma 1, and D, negative 3 comma 2. Outputs from our image are A prime, 4 comma negative 3, B prime, 2 comma negative 4, C prime, 1 comma negative 2, and D prime, 2 comma negative 3. So pause the video here, see if you can look at those inputs and outputs and decide what is the pattern. All right. If you did pause, you should have gotten the pattern is y equals y comma x. So the x and y values just flip. So we can test that out here in this example. First, I would recommend finding all of those coordinates. So A is 4 comma 3, B is 1 comma 0, and C is 8 comma negative 2. Then, if you remember from the last slide, the pattern for y equals x is you're just flipping the x and the y. 3 comma 4, B prime is going to be 0 comma 1, C prime is going to be negative 2 comma 8. Then we can come over to our graph and plot them. 1, 2, 3, 1, 2, 3, 4, B prime 0 comma 1, and C prime negative 2, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Which makes sense, right? You can see that if we connect these corresponding points, you get perpendicular bisectors. So, there we go. Now, if we look at reflections over the line y equals negative x, I want you to pause the video, try to see if you can figure out on your own what goes here. Alright, so it looks like if we compare all of the different points here, the x and the y are flipping values, and also both are opposites. So for A, we have negative 3 comma 5, or A prime, and then for A we have negative 5 comma 3. For D we have negative 5, positive 1. For D prime we have negative 1, positive 5. You guys can see that pattern. Now we're going to talk about reflective symmetry, which I think all of you guys have seen before. Really quick, just to refresh your brain. Reflective symmetry. We can draw these lines where if we folded along these lines, the picture would fit perfectly on top of one another, and F has none. So see if you guys can fill out the rest. I'm not going to show you because it's pretty easy. Now we can apply what we've learned to new problems. So we have learned that points are equidistant from the line of reflection. So if A is 1, 2, 3, 4 units away, then A prime has to be 1, 2, 3, 4 units away. If D is 1, 2, 3, 4 units away, then D prime has to be 1, 2, 3, 4 units away. And you see B is just one more from D, so B goes here. And then C is 1, 2, 3 units away. 1, 2, 3 units away. So then we can just connect all of these. There we go. And the same thing, and if you look at this, well, and then the same thing can be done here. C is 1 unit away from the line of reflection, so C prime is going to be 1 unit away. B is 2 units away, so B prime is going to be 2 units away. Same with D, and then A is going to be down here. We can connect these all. Super great. There you have it, folks. Reflections, super easy. I know you guys will get it, and that's all. You got it? Okay. Sorry. Still working.